So continuing with the example of moment of inertia, example number 5 is a mass of 1 kilogram is placed at 0,2,0 meter and another mass of 2 kilogram is placed at 3,4,0 meter. Find the moment of inertia of both the masses about z-axis. So 1 kilogram is placed at 0,2,0 means x coordinate is 0 means this, and y coordinate is 0 but x coordinate is 0, then this point where suppose this is 2 meter and z coordinate is 0, so this is the point where 1 kilogram is situated and 2 kilogram is placed at 3 meter on x-axis and 4 meter on y-axis. So this is point where 2 kilogram is situated, and we have to find moment of inertia of both axes about z-axis. So z-axis is perpendicular to the plane of xy plane, and I is equal to m1 r1 square plus m2 r2 square. Here m1 is 1, r1 means perpendicular distance from z-axis of mass 1 kilogram. So r1 becomes 2 meter square plus m2 is 2 kilogram and r2 is this perpendicular distance. So this distance is r2 and r2 by Pythagoras Pythagoras theorem. So r2 is 3 square plus 4 square root, this becomes 5, this is 5 square, this is 4 plus 5 square 25 into 250, this is 54 kilogram into meter square. Next example. Next example is 4 thin rod, each of mass m and length l, forms a square. Then what is the moment of inertia I about this axis? So I is equal to, first we talk, this is rod number 1, this is rod number 2, and this is rod number 3, and this is rod number 4. So first we check moment of inertia I, which part is due to rod 1. So which part, and this 0 is that part. Why 0? Because this axis I about which moment of inertia is asked is passing through rod itself, means parallel to rod. So the mass distribution is on the axis. So if on the axis mass is distributed, then the perpendicular distance from axis will become 0. So I due to rod 1 is 0. If we talk about this rod number 2, so the edge of rod number 2 lies on the axis. and the axis is perpendicular to the rod. So on the axis which is perpendicular to the rod and passing through the edge, the moment of inertia is ml square by 3. Same applies on rod 4, ml square by 3. And now if we talk about rod number 3, then rod number 3 is parallel to the axis about which moment of inertia is asked. So this is L distance far from the axis about which moment of inertia is asked. So we have to apply parallel axis theorem, and parallel axis theorem says that if two axes are given and one is passing through center of mass and about other axis, if moment of inertia is asked, then the moment of inertia becomes I center of mass plus ml square. Here L will be the distance between I center of mass and about I about which axis passed asked. So I center of mass is 0 due to 3 number rod. Why? Because I center of mass axis is parallel to the rod, so I center of mass becomes 0 plus mr square. R is the distance between two parallel axes. R is equal to distance between two parallel axes, so R is equal to L, so it is ml square. So 0 plus ml square is due to rod number 3. So this, so ml square by 3 plus ml square by 3, 2 ml square by 3 plus ml square, so it becomes 5 by 3 ml square. Now next example, about what axis would a uniform cube have its minimum moment of inertia. So the axis which is passing through diagonal have minimum moment of inertia in a uniform cube. Why this occur? This occur due to distribution of mass. So mass is closer to the diagonal axis as compared to any other axis which is passing through center of mass. Now example number 8. 4 solid balls, each of mass m and radius r, at the four corners of a square of a side A. Find the moment of inertia of the system or one of the side of the square and one of the diagonal of the square. So first axis is this and second axis is axis which is passing through diagonal. So if we talk about question number first, one of the side of the square. So about this axis moment of inertia, if we want to calculate, then suppose this is I1 and this is I2. So I1 is equal to, first we talk about this is pair and this is pair, then this and this. So if we talk about pair 1 and 2, so the axis is passing through diameter of these solid balls. So due to first solid ball, moment of inertia becomes 2 by 5 mr square. Due to second number ball, 2 by 5 mr square. Now if we talk about 3 and 4 number balls, the 3 number ball and 4 number ball are for a distance far from the axis center of these balls. And if I talk about this axis passing through center of mass of 3 and 4, and I suppose I say the moment of inertia on due to both 3 number ball I center of mass, then I1 part of I1 formed by solid ball 3 and 4 is I center of mass due to 3 and 4 is equal to 2 by 5 mr square due to ball number 3 and 2 by 5 mr square due to ball number 4. And the distance of this axis and this axis is between these axes is A. So by parallel axis theorem, I1 is equal to I center of mass plus m A square. So due to I is equal to I center of mass plus m A square, here three and 4 number balls are similar, so I can multiply by 2, and 2 into I center of mass is equal to 2 by 5 mr square due to 1 ball and m A square due to 1 ball. So this become 4 by 5 mr square plus 2 m A square. This total becomes 8 by 5 mr square plus 2 m A square is I1. Now if we talk about I2, then I2 becomes ball number 3 and 4 are the diameter axis along I2. So 2 by 5 mr square plus 2 by 5 mr square and double of 2 by 5 mr square due to ball number 2 and ball number 4. And if we talk about ball number 3 and 1, then this distance, we know that this distance is equal to A by root 2, because this angle is going to 45 and this becomes, because this distance is AB, so AB by cos 45, so it becomes AB into cos 45. Okay, so a by root 2. So plus, but due to 1 and 3 is equal to I center of mass plus mr square. So I center of mass is 2 by 5 mr square plus m into a by root 2 square. Okay, and this is multiplied by 2. So I2 becomes 8 by 5 mr square plus ma square. Okay, as a by root 2 square, a by root 2 square means a square by 2, and ma square by 2 plus ma square by 2, half plus half 1, so ma square.